The technology industry has spent the last decade obsessed with generating software as quickly as possible. But writing code faster created an unexpected mathematical problem, a $1 trillion bottleneck in the system required to check that code for errors. To understand this bottleneck, we have to look back at how quality control started. In the 1970s, IBM established a disciplined auditing process where developers would scan for defects at a painstaking pace of roughly 90 lines per hour. Eventually, the industry moved online. Teams adopted asynchronous pull requests to speed up the workflow. But while the interface moved into the browser, the core mechanic remained unchanged, human engineers manually scrutinizing the logic of their peers. This chart maps out the shift-left principle, the relative cost of fixing a defect across 4 stages: design, coding, testing, and production. Catching a flaw during design might cost $100. If it escapes into production, the cost spikes to $10,000. Human code reviewers have acted as the sole dam protecting massive corporations from the catastrophic financial ruin of an escaped bug. When that dam breaks, the damage is immediate. In 2012, a dormant code glitch bypassed the review process at Knight Capital. Within 45 minutes of the market opening, the system executed millions of errant trades and erased $440 million. The scale of these failures is expanding. A single faulty CrowdStrike update crashed 8.5 million systems worldwide, grounding global airlines and inflicting billions in direct financial losses. This pie chart breaks down the macroeconomic toll. According to the Consortium for Information and Software Quality, poor software quality costs the U.S. economy $2.41 trillion annually. The majority, $1.56 trillion, stems directly from operational failures and cyber incidents. Human code reviewers were already operating at maximum capacity. Then, artificial intelligence entered the market and accelerated code production far beyond human scale. Generative AI changed the physical limits of writing software. Tools like GitHub Copilot turned the labor-intensive act of typing syntax into a high-speed conversation, where natural language prompts yield instant blocks of logic. This line graph plots the adoption rate of these AI coding tools. Because developers can complete tasks 55% faster, industry adoption scaled from near zero to 85% in just 2 years. Coding 55% faster means developers are producing up to 3 times the total volume of software. But every new line of that generated code still requires a human peer review. This volume creates a significant backlog. Recent surveys show that developers are now spending 11.4 hours per week reviewing AI output, compared to just 9.8 hours actually writing new features. While AI successfully removed the friction of generating syntax, it effectively weaponized the code review bottleneck against human engineers. The tech industry recognized this workflow crisis immediately. It triggered an arms race to build and control the next generation of AI development platforms. Legacy tech giants are deploying massive research budgets, while agile startups capture extreme market share. The AI-native code editor Cursor entered talks for a $50 billion valuation after dominating this niche. This side-by-side bar chart displays the SWE bench metric, used to determine if these AI models produce secure code. The data reveals a gap. While 61% of AI-generated code successfully compiles, only 10.5% passes critical security tests. Institutional investors are currently betting tens of billions of dollars on AI models that still struggle to identify the security implications of their own logic. Because large language models generate code based on pattern recognition rather than security principles, they frequently reproduce unsafe patterns. Research shows that AI-generated code contains nearly 3 times as many critical vulnerabilities as human-written code. One specific vector is the phantom dependency. AI models will occasionally hallucinate fake software packages in their suggestions. Hackers actively monitor these hallucinations, register the fake package names, and upload malware that installs when developers run the AI-generated commands. This reality is reflecting in the workforce data. Despite massive daily usage across the industry, only 29% of developers report that they actually trust the accuracy of the AI output. The software industry successfully accelerated the development cycle, but in the process, they inadvertently automated the mass production of technical debt. To manage this influx, the industry is pursuing a paradox-driven solution. The only way to effectively review AI-generated code is using even more AI. This requires a leap from passive AI assistants to autonomous agents. These are independent AI engineers capable of executing, testing, and verifying their own complex tasks without requiring line-by-line human prompts. The financial markets are already validating this pivot. Startups building these specific autonomous capabilities, like Cognition AI, are achieving multi-billion-dollar valuations in a matter of months. The objective is a self-healing codebase. Specialized AI agents are segmented into distinct operational roles. One agent drafts the logic, a second audits for vulnerabilities, and a third deploys the patch. Under this model, the role of the human developer changes. Instead of manually typing syntax and hunting for bugs, the engineer becomes an overarching director overseeing AI labor. In this new workflow, the measure of a successful engineering team isn't how much code they produce, but how effectively they can secure and govern the machines producing it for them,